For today's lesson, we're still going to be covering 9.1. Only remember we had to split it up over the course of 5 days. So for our second day in 9.1, we're going to just really be multiplying. So today is a much shorter day. There's only 5 problems in today's lesson. And you really already know how to do this. It's just really kind of a matter of going through maybe your questions. So what we're going to be doing today is mostly just multiplying, or what I guess I would call it the distributive property. Notice we have a monomial times a binomial, and then really the same thing here, just we have a radical on both parts, which makes it a little harder. And then notice down below here, we have two binomials, and again, the same thing, two binomials, just kind of different numbers. And then down at the bottom, we have that quantity squared. So really, it's just, again, all about multiplication, okay? So let's take this first one. If we are going to be multiplying this outside piece, so the outside piece times this parenthesis, we're just going to distribute. Now remember, there is a 1 sitting out front of this square root of 6. So what we're going to do is we're going to multiply the whole number times whole number, so 2 times 1. And then we're going to multiply the square root times the square root. So square root of 5 times square root of 6 would be the square root of 30. And then that one's done. And then we're going to distribute again to the second part. And now there is no radical behind this. So in a way, it's kind of like there's a square root of 1 sitting behind it. So we're going to do whole number. So 2 times 2, which would be 4. And then we're going to do radical times radical. So square root of 5 times square root of 1. So that is just from the distributing part. And now what we just have to make sure is, can these go any lower? Now we know this one can't go any lower because it's prime, but now we have to think about the 30. So if you think about the multiples of 30, that would be 1 times 30, 2 times 15, and 5 times 6, and then what else? Maybe 3 times 10. I think that we've got them all. So notice there's no perfect, no perfect, no perfect, and no perfect. So this one is actually as low as it can go as well, okay? So this is called a composite, but it's not made up of any perfect squares. So this would be our final answer right there. And because these are not the same, we cannot combine them either. So that one is just simply done, okay? So if you want to pause it and try number 2, again, you know everything you need. It's just kind of a matter of, what do I do with this or what do I do with that? But if you want to give it a try first, you're welcome to, and then I'll go over how to get the answer, okay? All right, so if you wanted to pause it, hopefully you did. Now we're going to go ahead and distribute. Now notice there is nothing out in front of either one of these. So we just kind of in a way imagine that it's like 1. So it's kind of like 1 times 1. So we don't really have to write it. So now we're going to multiply the radical. So we're going to go 5 times 3. And then we're going to go variable, so y times y. And remember, this would be from your chapter 6, so that would be y squared. Okay? So let's just leave that alone for a second, and let's go ahead and distribute again. And we're going to go, same thing, outside times outside, which is just really a -1. And then we're going to go 5 times 75. Let me grab my calculator here. So 5 times 75. So I get 375. And then I'm going to go y times y, which is y squared. Okay, so there's my distributive. And now the same thing. I just have to go through and I have to ask myself if these can go any lower. So 15. 15 is made up of 1 times 15 or 3 times 5. We don't really have any other combinations that would get us to 15. So it doesn't look like the 15 is going to go any lower. So I'm just going to write the 15. But now the y squared. Remember, that's the same thing as saying y times y. So because I have a pair, one of them come out front. Okay? So I know I've done that one right. Now I'm going to copy the subtraction down, and now I have to do the 375. So the first thing I'm going to think about with 375 is 375, I know it's divisible by 25, because if you think of this like in quarters, you know, like 25 goes in there. So let's try that, because I know 25 is perfect. So how about we try 25 and 15? So I'm going to think of this as 25 times 15. And then actually I'm kind of noticing there's a 15 here and there's a 15 here. So that actually is going to be kind of helpful, okay? So let's take the square root of 25. So if we take the square root of 25, that's going to come out front. Now I'm going to leave a little space for that variable. And the 15 we already found from over here can't go any lower. So it's just going to be a 15. And then remember, like what we said, the y squared is really y times y. So since we have a pair, that's going to come out front. Okay? Now, notice our radical piece is exactly the same. And we already know it can't go any lower. So all we're going to do is we're going to put these front pieces together. So this is kind of like a 1y minus a 5y. So that would be a negative 4y square roots of 15. Okay? And then that would be our answer. Make sense? All right. So let's give number 3 a try. Now, if you notice on number 3, this one is going to be a FOIL problem, okay, because we have two binomials. So we're going to have to do first, outer, inner, last. We're going to FOIL this out. So we'll take it slow. We're going to go square root of 7 times square root of 7. So that would really be the square root of 49. And if you already know that answer and you want to just jot that down, you can, but I'm going to take it one step at a time. All right, now I'm going to do the outer. So square root of 7 times square root of 3 would be a plus square root of 21. Now we're going to take our second number. We're going to do this one, and we're going to do the inner. So we're going to go negative times this. So it's a negative times a positive. And then square root of 3 times square root of 7. And then we're going to go negative times this. So a negative times a positive. And then square root of 3 times square root of 3, like that. And now we're just going to do a little bit of cleanup. Notice this one right here is a positive square root of 21 and a minus square root of 21. So these are going to cancel, which you should have noticed that from the beginning because this is called the difference of two squares. Okay, when you have the exact same thing but your symbols are alternating, you know your middles are going to drop. Now, these two clearly are not the same. They're not the same numbers, but what I do know is 49 is perfect. So I have square root of 49, and then I have minus, and then I know the square root of 9 is perfect. So notice my radicals are gone because these were both perfect. So 7 minus 3 is 4, and that would be my answer. Okay? So if you notice number 4 is not the difference of two squares because what's inside the parentheses is completely different. I know you still have your alternating signs, but what's inside is different. So this one is not going to have the middles drop, but if you would like to pause it here and give it a try on your own, that would be really good. So hopefully you might have tried it. So I'm just going to go ahead and start again. First, now notice this does not have a radical. So I'm just going to go 1 times 4 and then square roots of 3 because there's no radical back here. So it's kind of like the square root of 1. So it's outside and then radicals, okay? And now we'll distribute again. So positive times a negative and then square root of 3 times square root of 3. So that's the first. And now the second. We're going to go 5 times 4, which is 20. And we're going to go 5 times this one. So 5 times a negative, which is like a negative 1, and then no radical times radical. So remember, this is sort of like having a square root of 1 behind it. So it's radical times radical, like that, okay? So now let's just take a look at this for a second. Well, first thing I'm noticing is these two pieces right here have the exact same radical component. Notice they both have the square roots of 3. So why don't we bring those two pieces together? We can go 4 minus 5, which is negative 1, square roots of 3. Now you don't need the 1, but you do need the subtraction or the negative symbol, so that's up to you, okay? All right, now I'm noticing that this one is perfect. So I have a subtraction sign, and then the square root of 9 is just 3, And then there's nothing really to do with the 20, so I just do plus 20 like that. And then I'm noticing that these are both constants. So I'm going to say a negative square root of 3. So notice how I dropped the 1, but I kept the negative. And now I'm just going to put these together. So negative 3 plus 20 would be a plus 17. So that right there would be perfectly acceptable as your answer. Or if you would rather put the 17 first and then do minus square roots of 3, that would also be acceptable because, again, order of operations, it's not going to change your answer, the commutative property there. So again, that's up to you. All right, so number 5, maybe let me get you started on number 5, and then then you can pause it and you can try it on your own. Please, please do not distribute this middle term, okay? Or sorry, this exponent. That is going to make you miss the middle terms is what my brain was thinking, okay? When you see this square, what you almost want to do is, in a way, like ignore it and then duplicate your parentheses like that. So what you have is 2 of the same. Now, it's the opposite rule as this one, okay? Remember this one, when they're exactly the same, but the symbols are alternating, the middles drop. This one, yours is exactly the same. The symbols are the same. So the middles won't drop, but they do have that special trick to them. So again, if you'd like to pause it here, it would be great for you to try this on your own before I go over the answer. Okay, hopefully you tried it. And so I'm going to go ahead and FOIL this out. So 9 times 9, that one's a nice one because there's no radical. 9 times the square root of 2. So remember, there's a 1 in front here. So 9 times 1. And then remember, in a way, there's a square root of 1 behind it. So you do outside times outside, and then radical times radical. Like that. Okay? Now I'm going to do, so that was first, outer. Now I'm going to go inner. And so again, I'm going to do the constants or outside numbers, 1 times 9, and then radical times radical. And remember, if there's not a radical there, you just think of it as the square root of 1. So that would be 2 times 1. And then now we're going to go last. So 1 times 1, and you don't have to write that if you don't want, and then radical times radical. So 2 times 2. Now again, I'm noticing a couple things here. I'm noticing that these are exactly the same. So I'm just going to do 81. And then I'm going to put these two together. So 9 plus 9. And then the radical doesn't change. And then on the end here, I'm noticing that the square root of 4 is perfect. So the square root of 4 is just 2. So I'm going to say times 2. So this 1 times 2 is really just a 2. Okay? Now, I'm noticing I have a constant here and a constant here. So I'm going to put those together. So 81 plus 2. And then now I have my radical. So that just kind of tags along. And I notice that this can't go any lower because it's prime. Just like up here. The 3 couldn't go any lower because it's prime. It's not going to go any lower. Now, once again, if you would rather put the 18 square roots of 2 first and then the 83 second, that would be acceptable as well. It's not going to matter. It's not going to affect your answer. Okay? So really today's lesson is just really kind of the distributive property. And then when you get 2 binomials, you can FOIL. But remember, FOILing is the distributive property. Okay? So that wraps up our day 2. Remember, we're going to do 5 days of this because there's so much content.